Flowline machining is a new strategy to machine a region of multiple surfaces independent of surface parameterization. It is similar to the existing strategies surface machining and parametric offset finishing, but with the added advantages that machining of undercuts is possible, multiple surfaces can be machined, the toolpath passes are not determined by the surface parameterization, and the region being machined is not forced to be an entire surface or parametric box. In this first example, we are going to select the surfaces which comprise the outside radius of this fixture and machine them in one toolpath. This was not possible using surface machining as there are multiple surfaces. I'll first select the surfaces and then create an embedded pattern by inserting in the model. When I turn off the surfaces, I can see that I have one pattern which needs to comprise of at least 4 segments. 2 segments are the drive curves, which dictates the start and end passes, and 2 segments are for the limit curves, which limit the length of the passes. Together, they should form a closed box containing the region to be machined. There is an additional option to include an intermediate curve between the drive curves as an additional method to control the blending between them. I will now take this embedded pattern into the curve editor and cut it into 4 segments. It is important that the segments form an entirely closed region to be machined, and the user needs to consider that the drive curve shape controls the form of the toolpath passes. Therefore, the curves that flow smoothly along the length of the curve without sharp changes in direction produce smoother toolpath passes. I'm happy with that, but I've noticed that this segment is not full, it's in 2 parts. So we need to go back into the curve editor and merge these selected segments into one. PowerMILL has just informed me that I now have 4 segments in that embedded curve. I'll turn the surfaces back on, and now we'll create the machining toolpath. I'll now go into the strategy selector, select Flowline Finishing. By entering an appropriate toolpath name that associates with this area of the job, entering the newly created embedded pattern, and upon selection you will notice that these embedded pattern segments did change colour. This change in colour is significant. The green segment is the start drive curve, the red segment is the end drive curve, and the 2 blue segments are the limit curves. Now I'm happy with the rest of this in here. Form strategy. 5 more ball nose, I'm happy with that. Tool axis is vertical, again I'm happy with that. There's an additional requirement in here that if we're not happy with any of the intelligent assessments that PowerMILL has made into what we require, we can access and change ourselves. If we look at the 4 on the bottom, the curve configuration, the first swaps the drive and the limit curves over. The second swaps between each of the limit curves and drive curves. The third option changes the direction by this purple cone. And the 4th one toggles the machining area, outside or inside. I am happy with that. I can press calculate. When we
The
simulate
toolpath is now
this toolpath,
complete.
we will see that
We will
this
now
whole
remove this
capping
machining
rad,
form.
the external male fillet radius, has been machined in one continuous toolpath, giving a nice smooth flow from the first start drive curve towards the end drive curve. When we look at the next toolpath that was going to be created using flowline machining, we're going to utilise 5-axis machining capabilities to machine the whole of this wall around the rad at the top and the top surface. When I turn on my undercut shading, we can see this wall here is undercut. The majority of the job is accessible using a vertical tool axis and utilising a 3-axis machine. However, to machine round here, we'll need 5-axis capability. The 5-axis strategy we're going to use is positioning the tool axis using from a curve. Creating an embedded curve similarly as you've seen in the first example, that has set my drive curves and my limit curves, but also I have a tool axis curve which I will use for the tool. When I look at the settings for the toolpath, we can see that the green at the top indicates that's my start drive curve, red at the bottom the end drive curve, and the blue are my 2 end limit curves. This white curve is going to be my tool axis pattern. I'll now calculate this. Now, the flowline toolpath has been created, and we can see one toolpath has machined the top surface, the rad, and the sidewall all the way down to the fillet at the bottom. And also in so doing, it has machined the undercut side wall. When we look at this toolpath in here, we can see that while the results have been very, very good, we can still make out that some of the passes here are not following that capping rad, are going round. Now, Delcam provides an additional control to improve this toolpath. That additional control is by putting in an intermediate curve. Now, I'll dismiss this form, turn this toolpath off, and I'll remove that curve that was embedded which controlled where it was. The intermediate curve sits just underneath this rad that goes around the top and extends all the way along the job to the end. So we've just taken that edge and has driven a curve around. By then including that into an embedded pattern, we've now provided additional control. I'll show how this is done. Here's a copy of the embedded pattern I first used. I'll activate it, and then I'll go at the top and I'll pick curves to add into the active pattern. Turn the intermediate curve on. I'll just select it and collect. That has created an embedded pattern with that intermediate curve in. Now I'm going to turn these off. I'm going to activate a predefined strategy with its settings and recalculate. So the flow 3 with an intermediate curve, happy with all of the settings, tool axis again, tool axis smooth. I'll put it into an isometric view so we can see. With an intermediate, flow 3, and calculate. We'll now compare the two toolpaths. Where previously the toolpath had no additional control with an intermediate curve, it wandered. Now we put the intermediate curve in, it provides that additional control. When we see the radius round here, no longer does the toolpath drift up as did previously in white. It now maintains a constant height in green, a much improved toolpath. There was a 5-axis flowline toolpath that's being created. We will now simulate this so we can see more easily. You'll see the tool starts on the first drive curve that sets the start of the first pass of the toolpath and progresses along the top face towards the end drive curve. Positioning the tool lower down, we can see now that smooth flow has continued throughout the toolpath.